if you're just a consumer and you want to buy this robot, I will have this robot for sale that you can buy that's completely finished for you. And I can even like help you use it. So that'll be on the website, right? If you want to build a kit, if you want to buy a kit that has all these parts already inside the kit, and we're going to be creating all the video instructions here, and hopefully you have comments and we can kind of create a nice community and a dialogue. Welcome back to DreamCloud and the Millennial project. This is day one, in a way, of Millennial 1 Robotics. So if you're following along, we've been talking about computers and new cities and how we can use tech to kind of redevelop the country. And all of those have been kind of like macro perspectives on how we can improve our economy and our domestic supply chain when it comes to tech. But as I've been kind of, digging in and getting my hands dirty, I'm starting to build a robot. So the Millennial 1 robot will be what we produce. This, you might say, is kind of like what I'm showing you. This is the like eventual robot that we could build, right? This is just a drawing, but it's like a goal. And this is what I think a robot should look like, and the kind of attachments or the kind of capabilities it should have. This is a very simple robot that I am kind of using as like a base because I really like this omnidirectional wheel kind of cube format. So I'm going to try to apply that to as many things as possible. And in order to build that robot, we're going to start building this robot. So everything right now today is going to be explaining this little adorable robot to you. Basically, what you're going to be seeing right now on the screen over here is its face. So if you could just imagine, this is a tablet. This is modeled on a Samsung A7 tablet. And this over here is running the code in Dart, which is a Flutter language, or the language of Flutter, which is kind of like the framework or the ecosystem where you code, right? You build Flutter apps with Dart. So you code them on Dartpad. Dartpad right here, .dev, is where you can go ahead and kind of make these mock-ups. This is like a really simple one-page app that it'll run right here in this little window. So if you're just designing something like this, even though it is 300, 400 lines of code that's running this animation right now, which I'm going to explain to you fully. What we have here is the canvas. This is ChatGPT, right? This is the canvas where you code. Here is the same code right here that we just popped in there, which actually runs it. We coded it. We got it from ChatGPT. And just to give you a quick rundown, this is, I can't even scroll. This is the entire conversation. Basically, that took me 12 hours to make, starting from just talking to ChatGPT and saying, "Hey, I'd like a robot face, and code me something in Dart, and we'll use Dartpad." And it just kind of just coded a robot face, and that's how we started. So that was like the original, just request from ChatGPT, and then we started refining it and refining it and refining it, and creating 12 hours of video doesn't seem practical. So what I'm going to do is kind of explain to you a couple of things here. But just know that you can ask ChatGPT anything you want to create. I said we're making a robot face, so it knows we're making a robot face. And I said, let's start with a couple of eyes that are circular and just put those on the screen. And what it did, which is really cool, and I'll just show you that right now. So if we jump into, this is the actual file running the simulation right now. So our first couple of parameters that we can change, right? This is the top of the file. And it gave me this setting area. And on a full file, on a running app, you wouldn't have these just embedded in your code. These would be, changeable somewhere else, and maybe even, locked by some authorization or something, right? The file, the right file, because these are fundamental to how it looks. So right here, oval width, oval height, right? This is actually an animation that is doing that right now. So that is an oval movement from here around and then back again. And that seems simple, but actually I started with a up to the right arc down to the, down to the right. So those three movements, and it couldn't figure that out. And it kept having the eyes arc upside down. Cause also just keep in mind in this, you're coding in Flutter using Dart, and it thinks the positive numbers that you're using are pushing things down on the screen. So there's kind of like an inverse number system here where some of these numbers, they're offset, but they're offset in the down direction on your phone, because that's how you stack things. Kind of, you build them from the top down because that's where you start scrolling from. So that's what you should definitely know about your Y coordinates at least. So the shy offset is 30. That's when he finally in the last. So let me explain to you what he's doing, because that's a little more nuanced. But basically know that it's not only coding the thing. I can go in and change these parameters and reset it. Like, let's just say I change it from 30 to 60 so we can really see the difference. And the oval is going to run way over to the right and the left, right? And that's going to make him look like he's really searching from side to side. That 60 is just an increment of pixels. See, boom and back. I just feel like that was a little wobbly for who this robot is. I feel like he's a little more chill. So I'm going to put it back to 30. But those parameters, give you the ability to come in here and really just play with the animation or play with the scale of things. So these are all animation, right? Shy pupil offset. That's basically how much the pupils narrow together as they're lowering right there. And then the width shy, this is the mouth. So the mouth comes in and it goes from 140 to 60 pixels. So I can control that. And then the shy pupil, the shy offset is how low it goes. So it goes 30 low, 10 in, and then, but how did I get those values, right? How did I get these original values? Well, originally I just started asking ChatGPT to render me a circle, 2 circles, offset them. So the face offset, I said wrap it all in a face so I can move the eyes and the mouth together. So that's 40 down from 0, 0. Wherever that point was, it's 40 down because the Y offset, like we said, is in the down direction, even if it's a positive number. Moving on, face offset, eye width, eye corner radius value, that would be this right here. So I can change that, right? Pupil radius, that's obviously the radius of the white one right there. Pupil offset X, that's offset in the inner direction. So that would be along the X value, it's 20 in. Offset Y is 10, it's 10 down. So it's pretty centered. But because this is also dropped 40, these numbers add together. So the glow size is just the ring around the outside. And then the smile offset 100 is the distance here, this smile, because when I first loaded it, it was way up here. So that just gives me a nice little distance here. And then 6 is the width. So all of these parameters are basically drawing this thing, right? And then you got the colors. I pulled these in. And then just to recap, if you're doing this in Dart, just know that this number, OXF, or 0xFF, that's all Flutter code. And 0xFF is fully opaque. And then this is the hexadecimal, I guess you would say, code for the color. Or you can choose white. They have some colors baked in, but I wanted to get precision colors. So you just go get those from like a little sampler. Okay, and let's go back up to... Okay, no more adjustments down here. Let's go back up to where it actually runs the loop, because basically this is a loop, right? See this right here? Blink timer? It's a 19-second loop. So it runs this whole thing and then starts over. So just think about it that way. We have a group of objects, right? And then we have this loop right? And then the actual parameters of each part of this loop is up here. And then before we get into that, we can actually control all those inputs there. So that's feeding into this, and then that's giving us what those are actually going to look like when they're called. So this is just going through the loop cycle, run cycle. Basically, it waits 1 second, and then it does the gaze controller, which we decided to be looking left and the right. And because it's controlling both eyes, we call it a gaze. So we made all this stuff up. And then it does a blink, right? So it gazes from left to right, and then it's 6 seconds. It's done with that, and it does its first blink. And then it delays, and it smiles. So 2 seconds later, it smiles just like that. And now you would think the smile would be easy, but it didn't know to raise the endpoints of the curve of the smile. It thought it should drop the middle, which doesn't make any sense. When you smile, you kind of raise your... So I had to go in there and figure that out and, kind of reprogram that. But that's a nice smile, right? And then it blinks twice, right? So do blink right there. And then it reverses the smile controller. So just think about it as it smiled and then it reversed that action, giving us a flat line. But what we did was right at the same 12-second interval, right? So this is 2 seconds later, it ends the smile. After it blinks twice, it ends the smile. And then we transition from a smile in the same second down to this guy right here, the shy controller. And that gives us the lowered eyes and the kind of tucked in mouth. So if you think about it that way, we go back up to the shy controller, which I hope I will be able to find right here. And now this guy is telling this area, pulling this information right here, smile width, right? What to deform to, what the default was, what the shy offset is, so how much the pupils will move down and how much the pupils will move in, the offset from the center, basically the offset inside, we'll say. So that's how it moves. And then when it's done with this whole loop, right? Then so from 12 seconds, it does the shyness. It goes down quickly and then holds it and then kind of releases it, right? And that was just communicated into chat. And then at 17 seconds, it does the final blink and then it starts over at 19 seconds. So basically that is, you can think of it as 20 seconds of life given to a robot. It took me 12 hours coding on ChatGPT. And if you really slow down and think about this, ChatGPT is in a way creating the code. Even though it's code for me, there's a couple things I want to tell you right now. Okay, so ChatGPT is kind of building itself a body at this point because I'm using it, but it's really making, some of these decisions on its own. And it fully knows, which I don't know if it's aware or not, we can have that conversation later, that it is creating a body for it to run on. So this whole project is, this thing right here is going to be the interface. That's why we're programming it on Dart, or in Dart, I should say, as a Flutter app, so that it can be used on Android and iOS devices as an app on a tablet. So the point is to get this thing onto a tablet. And the way you do that is to create an app, because that's what tablets run. So it's almost like we're thinking about this backwards. If I wanted to use a tablet, what would I need to create to access that tablet and all the hardware? So that's what I'm kind of doing now, is saying, I'm building a robot. How can I use existing hardware? We already have tablets with cameras and screens and all this processing power, and they're only $100. So the face of my robot is kind of already been created in a hardware sense. I just need to be able to tap into it. And that would be an application that the user could just click on to open up. That's brilliant, right? So how do I make this AI powered app responsive, or what kinds of things is it going to do? Well, the first thing it's going to do is have a face that's going to be animated that it can cycle through. So this 20-second loop you're looking at kind of represents maybe the default, the one we go with right now, because it's 20 seconds of, a robot that's alive, and we can just kind of have it run ChatGPT responses, because I kind of want to move on to the real difficult parts of this, which is building the brain, integrating it into ChatGPT, and then almost creating like the nervous system. Like, as you'll see, So right now I want to show you the actual version of the robot that we're going to be building. So if you look at this little image here, this is going to be the tablet like I just described, and it's going to be attached to this body. So we're actually going to make the body with a 3D printer, and we are going to use we're going to use a kit, a robotics kit that I bought offline that's $100 with a $100 Raspberry Pi computer. And this is an actual computer. This isn't just like a robot controller. This isn't an Arduino. This is a computer that runs Linux. So think of it as we're giving this thing a computer on the body to handle what is the robot operating system, which will control all of the different parts of the robot. This Raspberry Pi is on the robot chassis, and it is responsible for moving the wheels and the camera and navigating the robot. The Raspberry Pi computer will actually talk to, through Bluetooth, the tablet eventually as a device through a couple different kind of translations, because it doesn't just talk one-on-one or directly. It needs to be translated a couple times, but it'll be able to kind of control the camera to be able to view the outside world. So literally, like we'll say the part of the robot operating system that's going to handle navigation or facial recognition is going to be able to listen to signals that are being broadcast, which are called topics in robotics, which is like an image, right? So it's going to be like broadcasting this image, and then on the robot side, the facial recognition can kind of listen to incoming things and almost like apply all these different algorithms, you might say, to look for people or to listen for things, to move out of the way if it sees something. So the robot operating system is basically it, and I'm going to be building this, so I'll show you this. So this is just kind of like a preview. I just want to give you like a summation of, we're building a robot. This is kind of day one-ish, just so I have a record of this for myself as well. And so the Raspberry Pi is on the chassis, and then we're using this kit, and it already comes with this nice expansion kit, which is basically like a power controller for and like a motor controller and like a power converter. So it's like this thing that you plug everything into that then like feeds the Raspberry Pi the voltage it needs so we don't fry it, but it also supplies enough voltage to the motors so they can actually spin. So there's like a range of all these different voltages. See, this is why robotics is really like interesting in this really complex field, because it's kind of like you're learning about this different species, right? Like now that we have AI as the brain, and we have, you could say AI is the mind, right? And then the brain is actually the Raspberry Pi, right? The face is more of this like animation, right? The software. Or you could say the expression is the animation, the face is the tablet. So it's kind of like, if we're speaking about this thing, we are speaking about the physical object of the thing, but then also the alive version of the thing. And to me that's really interesting, right? Because there's like how does it control the motors, as in like how does it control the muscles, and there's that part of the robot that we'll have to figure out. But then it's also like, how does it figure out how to send a message to the motors that it should go around something or go over something, and that's kind of the reasoning. So it can do all this. Robots can do all this now. And what I'm going to show you is if you're curious about this and you want to actually make something that's a little more practical. So let me just tell you what this is going to do. All right. So we got this little robot, and then this last image I'll just show you is maybe the robot with arms. And I think maybe for now we'll just have the arms swing out in the direction that it's traveling, just so it can kind of like brace itself if it does hit something and fall over. I'm not sure what the arms will do for now, but we'll just kind of say, the first couple versions will just be about the legs and the maneuvering. But so this robot will be able to launch the interface on the app. It will start listening to you. ChatGPT will be running in the background. It might even start talking to you and ask you questions. You'll be talking to it just like a chat app, just like every other chat app out there. And this little animated face will be playing as the UI, and you're just talking to it. And maybe it's triggering all these different AI UI responses that make it seem more animated in the future. For now, we have one screen, which is what we showed you today, right? And then chat is going to be absorbing those responses and sending information back either as a response. If these prompts are more about the robot moving around, like if you say go away, obviously the robot is going to need to take that literally and tell the autonomous driving system, which is on the Raspberry Pi, to figure out a way to move away from this person within the space. And then what we can do is have it just roam autonomously. So the first thing this robot will be able to do is kind of just come up to you and look at you and talk to you using ChatGPT, but it'll have its own little face, which we've designed today. And then when you say go away or I'm busy or whatever, something dismissive, it'll go roam and kind of map your house, and it'll have a LiDAR system on it. So it'll be mapping its whole environment. And again, it sends that information down through along as a topic, right? It sends that message back to a system on the Raspberry Pi which is running Linux, that is going to map a 3-dimensional space or a 2-dimensional space probably of your house or wherever you are, so that it knows its location. And then it saves that, so that it saves its orientation, so that it's when it goes back to move around, it knows where it is. So let's just say the robot is kind of moving around your house and just, kind of bumping into things, or maybe it's making noises. And I think this kind of like standby autonomous mode can be where we have fun with it. And it just kind of becomes a little menace or something. And then when you say, come here, or something like that, then the robot will kind of look around for people, and then it'll go over and respond to the person who is perhaps making the most motion. So all these things are kind of like steps that already exist. All these are pieces that already exist. These are frameworks. There's even code written for this. It's just kind of putting it all together and delivering this little package. So the tablet is the interface, like we talked about, and that has the microphone, and that has the camera, and that has the screen. So all that's kind of invented. We're tapping into that. So you'll be able to kind of have this tablet head or brain, or skull, with this intelligence inside, using the mind of ChatGPT, and then plug it onto this robot body and have it connect to Bluetooth, and then animate the body. So then when you say something like, come here, it'll look around and it'll find the person who's moving or something that's moving, and it'll go in that direction, right? Then you can say something like, hey, record a video of me. And so it'll access the camera, and it'll have a video recording kind of, screen built in there, and it'll record you, and then it'll say, okay, save that video, and it'll download that to your photo. So basically it'll do a couple different things. It'll be interactive. It'll do what a tablet can do. And that's just the beginning, right? That is, to me, like the minimal project that I need to construct to kind of get into this thing. And by the time I'm done with that, I'm going to know a ton more about robotics, and you're going to know a ton more about robotics, because I'm going to show you this process step by step. So basically we're going to go from being a hobbyist, right? Like I am right now, kind of just buying a 3D printer and just building my own computer. And if you're going to be looking for a good computer, let me help you build a computer. Just click on the video on my page that explains how to build a computer. And the reason this is needed is because the RAM for all these programs, especially for the CAD programs that you're going to be running, need to be high. Blender, so you're going to need like a graphics card, and you're going to need high RAM. You're going to need a fast processor. You're going to need a good computer. So yeah, if you're interested in learning about how to build computers, and then how to take those computers and use 3D printers and other tools to make robotics, then follow along. We're going to be setting up that computer in Linux. We're going to be running Ubuntu 22.04, I believe, which is for robotics. We're going to be downloading ROS. We're going to be running nodes. We're going to be sending messages over topics. We're going to be doing all of the stuff that has to do with robotics. And we're going to be doing all of our workflow in VS Code, the app that you're going to download to be able to code all these things. And you can download that on Linux or OS or Windows. And then inside of VS Code, you kind of like download the package, which is called Flutter, which is the environment, which means that you're coding a mobile app. And then in that framework, you're going to be coding in Dart, which is the language. And I know this is very confusing, and I'm just getting this stuff right now, but you need to know what you're building before you start coding. So the fact that I know this is going to be on a tablet and that I want to kind of use the tablet, the brain, and I want to, have an app that can access the camera and access the microphone and stuff like that, I need to be developing in the Flutter ecosystem, right? I really need to be designing in the Android and iOS ecosystem, right? But to get to those two, they created Flutter with Dart that can basically splice one computer code into those two different languages for implementation in their app stores. So that's where we're going with this. If you're just a consumer and you want to buy this robot, I will have this robot for sale that you can buy that's completely finished for you, and I can even help you use it. So that'll be on the website, right? If you want to build a kit, if you want to buy a kit that has all these parts already inside the kit, and we're going to be creating all the video instructions here, and hopefully you have comments and we can kind of create a nice community and a dialogue about this whole process, then leave those comments. So the kit that you can buy is basically going to have all of the parts already inside, and it's going to have links to all of these instructional videos, so you can actually do the same thing and build this yourself. And here's the fun thing, right? So we're doing this in Dartpad, right? We're creating this face right here. So what we can do is actually have everyone access to a file that will allow them to kind of change these values. And we could have one that's more user-friendly on the app, where they can change the eye color and change the eye size and change all that. Or we could have something a little more developer-friendly if people are interested in creating their own face. So what I want to do is not just have this be a product where it's our product and it's our IP and we only sell it. I want to kind of make it a little more open source, so that you can download this file and you can print the shell, and you can order a kit of parts that'll give you the wheels you need. These are omnidirectional wheels. You have 4 motors, so you need a motor controller with 4 inputs or outputs, basically communication channels. You're going to need inputs for a camera. You're going to need inputs for LiDAR. So there's a lot of different ways to approach this, and I want to make it simple for you to kind of get started and copy what I do and have this thing running on your own tablet and build your own robot chassis, or buy the chassis from us, or 3D print your own, or completely just follow along. And if you have any questions, I bought a lot of this stuff on Amazon, and yes, a lot of it was shipped from overseas. Not a lot of this stuff is made in America. And that's kind of the bigger drive of this whole concept, is to kind of push tech education and robotics education and make it fun. But also, don't just make it crazy, because a lot of the stuff I'm seeing on YouTube is just I made this $20,000 robotics project because I have this YouTube budget and I need to make crazy videos and kind of, keep everyone's attention. But I'm not going to be able to follow along. At that point, the budget is just too big. So what this budget is $100 for the robot kit that I bought, $100 for the Raspberry Pi computer that goes on it, right? So those two things are already an autonomous robot, and that will run Linux and ROS too. So we already have that. And then a tablet, right? An A7 Samsung tablet. That's another $150, right? So all of these things, a wheel kit, how much is that? So we can be all in on this thing. A 3D printed case. How much am I going to charge you for that, right? Because this case isn't on the market yet, and we're going to have to 3D print all of these for now. Maybe we can talk about getting some clean, injection molding so they look nice and they feel nice. But we could also just 3D print the case and kind of sand it and maybe give it a coat of paint. So all these are options. Basically, what I'm trying to tell you is that I'm going to be going from a hobbyist who is interested in computers, who is interested in design, and who is interested in actually building things with modern technology and using AI to implement strategies. And I've noticed that all these things are just tools, right? All of these coding platforms, even a robot is a tool, all of these languages, all of these protocols, all of these operating systems, all of these devices, these are all just tools to get you where you want to be, right? And you have to learn how to kind of integrate all these tools right now. Right now, we're kind of at the new age of what I would consider like the consumer robotics. And obviously there's big companies making big moves like Tesla, like Boston Dynamics, like Sanuk, I believe. There's these kind of institutional robotics companies that have these huge budgets, or they're funded by endowments or universities. But this is going to be a robotics program that is taught to you by someone who never went to robotics school, who never got their engineering degree, basically teaching themselves how electricity works. I'm really comfortable with learning a lot of new information fast and rapidly, and then implementing those strategies in my own designs. So I'm going to be doing that, and hopefully you'll follow along, and then maybe you'll do something that I didn't see, and we can communicate. So I really do want to create this community where we're building robotics together. And this is the Millennial 1 robot. This is the face. This is the code for it. For right now, this is just the animation, the 400 lines of code. ChatGPT wrote it. So basically think about it as we're building this robot right now, and we're going to be giving the mind of ChatGPT a nervous system, which is the ROS, the robot operating system which runs on Linux, which runs on the Raspberry Pi, which is in the chassis of the robot. That's the nervous system, so it can connect to all the sensors and it can actually navigate. And then there's all these layers of autonomous, robotics programming that's going to be running on Python that's in there, and it's going to be connected to ChatGPT, which is a large language model. So this is going to be like everything you need to know about what's going on in robotics, how to tie it all together, and how to do it on a budget. You could do this at your house. You could create this whole studio. I'm going to show you exactly how to build your studio. All my computer components just came today in the mail, so I'm going to be building that computer for you. We'll be setting up the 3D printer. We'll be setting up a workstation, and we'll be, troubleshooting along the way. And here's the thing, ChatGPT or any of these big AI models, they are now your specialist in the field. So you just need to have the ideas. You just need to be inspired by technology. You just need to want to move forward with an idea, and you can implement anything. I guarantee you this. And you can just use ChatGPT as a specialist who can inform you more. You have to learn more. Obviously, you have to keep learning, but you can't be discouraged by, I don't know this thing, or this skill is too hard. You need to ask more questions and do the design feature, because a lot of this comes from asking ChatGPT to generate images for me. And then there's a feedback where I say, oh, I like that, but I want to change this. And then we get these final images, which are, drawing renders or diagrams of these robots. So then I can start moving on from the design phase within a couple hours. Sometimes I will have an idea of a robot and I'll get this finished image within 30 minutes. That's unheard of. So right now you can do that. And then I had this idea for a robot face, and I opened Dartpad, and within 12 hours, I had this finished 20-second animation. It's beautiful. It runs on an app. It is an app, and we can move on. And now I can start doing, the hard work, the integration with the ChatGPT. So basically, what I'm going to do now, the next video is I'm going to take all this, migrate this over to Visual Studio Code. This is their documents platform where you can research. I'm learning about their GitHub Copilot, which is AI built in. I don't want to pay for this. This is a subscription. So if you're out there and you want to sponsor my GitHub Copilot license, and I'll show people how the AI is used on Copilot. I'm definitely looking for sponsors for this. This is a robotics project. I cannot continue to fund this. So if you're interested in robotics and you want to be a part of something that has to do with building simple robots that can, navigate around your house and kind of interact with you in a cool way, this is going to be a great robot. And kids are going to love it, and parents are going to love it, and students will be able to build their own robots using this platform. It's going to be amazing. So stay tuned. I got a lot more for you. We haven't even started building the body. The Raspberry Pi is still in the mail. So thank you for joining me, and thank you for letting me explain this. We have so much ahead of us, so stay tuned.